हेलो एंड वेलकम बैक टू माय चैनल। और आज के वीडियो में वी आर गोइंग टू स्टडी अबाउट द डेटा पार्टीशनिंग टेक्निक्स फॉर द डिस्ट्रीब्यूटेड सिस्टम. So basically when the system scales from let's say n servers to 2 n servers to 2 n server nodes, we should actually get the 2 times of the performance. This 2 times of the performance is only possible by the good partitioning techniques. Actually, the good partitioning techniques helps in even distribution of data among the different kind of server nodes. So let's see what are the different kind of partitioning techniques in this video. So the first one that we see is range based techniques. What happens in this is, let's say we have some key to value database, and then we have keys with in some kind of alphabetical order A to Z. So we do the distribution based on the range. Let's say A to G some kind of distribution, H to P one distribution, U to Z another distribution. So in this way we are basically partitioning the data based on the some kind of range. It is very easy to look up. If you find something, let's say coming from B, we will go and look into the first segment. But the thing is, it can create hotspots. So let's say a lot of range of the data is available in this A to G. And a particular server is going to do a lot of work, and then it is going to be a hotspot for us. Let's say server 1 is going to do the 83% of all the work because the server 1 contains 83% of all the data set. That's why it is an hotspot. And in this, we have the uneven distribution of the data set. So this is good, but not very good things. There are cons, there are more cons, but there are some pros also. Let's look at another technique, and it is called as hashing based techniques. So what happens in hashing based partitioning technique is we have the data distribution in randomized order. So the data distribution is not based on some kind of particular range, but it is particularly randomized. So let's say we have a data key. It passes through the hash function. This hash function produces a number. And if this number needs to be mapped to a particular server node falling between 1 to n, we do the modulo operation, modulo n. Whatever the remainder is, that is our server node. Let's say we have 325 modulo by some kind of number k. So whatever we remainder get, that is the rth server node where the data is going to sit. In this way, we have hashing based partitioning technique. But the problem is if we move from let's say n to n plus 1, our math changes. So that means we have to remap the data completely again. So instead of 325 modulo k, we move to k plus 1. That means every data point needs to be remapped. This is going to be troublesome for us. So it creates a trouble and it becomes very slow. In order to solve this problem, we get something called as consistent hashing. So consistent hashing is also same, but with a slight catch. Instead of putting things in the linear manner, we put it in the circular manner. And then we move into the clockwise direction so that whichever is the next node that we are getting, the data is mapped to this particular server node. The same thing is happening over here. We have a data, we have the hash function, then we take the modulo, and then we do the get some kind of number, and that is going to be mapped to a server node. So let's say we have a data key k1, then we move into clockwise, k1 goes to 2. If we have k2 and there is a server 3 which is next to it, we go to server 3. So let's say k3, k4, k5, and then we have our server 4. So all this k3, k4, k5 will go to server number 4. How are we getting k3, k4, k5 places over here? By using the hash function and then taking the module operation. So we move clockwise and all the keys are assigned to the next node. If node is added, only the total number of keys by server is that fraction of data is mapped, not all the things. Because let's say a server node is added between S4 and S5, already present S4 and S5, there is S6 added. So whichever is data is falling between S6 and S4, this data has to be mapped. Instead of 5, this needs to be mapped to the 6th one. So this partially solves our problem, and this is the better partitioning technique. Let's look at another concept. So finally, we come to virtual nodes. So basically, virtual nodes is very good. So let's say we have our hashing and consistent hashing. The placement of servers can actually still cause hotspots. So we are moving into a round kind of fashion where we are placing the server, but instead of leaving the gaps between two servers can be placed one to each other. So that means all the work is being done by this particular server for all the keys falling over from this to this. That means this server is going to become a hotspot. So even though it is randomized, but randomly two servers can be next to each other. Once they become next to each other, one server is going to become a hotspot because it is going to do a lot of work. So this is something that we are going to tackle. So what happens in hashing, plain hashing in a linear thing? We split the data into predefined number of partitions. Let's say we define the number of partition to be 100, and we know that we will split the data into these 100 things only, 100 buckets only. These buckets are basically virtual nodes. And some number of buckets are actually mapped to the physical server. So let's say if we have 100 nodes, out of 100, each 25 are divided into 4 servers. This way, each server is going to work equally. Okay. So even this problem has a, let's say, remapping problem, but at least the hotspot won't be there. So when we go to the consistent hashing is also same. So in this, we think that we are replicating each server multiple times. So let's say we have SA, SB, SC, and SD as 4 servers. Then we are going to create 25 replication of each servers. By 25 replication, I just mean the 25 points on our circular node, circular ring kind of thing. So that means this node will have 25 cross 4 partitions which needs to be mapped to the 4 server nodes. So basically these are buckets. All these 25 things are buckets, and each set of 25 buckets are mapped to a particular server. What does it actually happening? So we have 25 partition that is going to be mapped to server A, 25 partition that is going to be mapped to the server B, 25 server C, and so on. So this way, our data set will be divided into these things. We have a data, it passes to the hash function, some kind of number is generated, and then let's say it is going to the virtual node of server C. Once it is going to the worker node of server C, that means server C is going to tackle. So this is our partitioning technique. We will see something more good, important things and exciting things in our next lecture.